We are joined here today by Dr. David Kilby. Dr. Kilby is an associate professor at Texas State University in San Marcos. He received his PhD from the University of New Mexico in 2008, where he studied Clovis caches. Today, his research interests include hunter-gatherer archaeology, Southwest prehistory, the organization of lithic technology, paleoenvironments, and landscape archaeology. Since coming to Texas about 4 years ago, his research has focused primarily on Bonfire Shelter in Val Verde County. His most recent publication, The Paleoindian Southwest, co-authored with Bruce Huckle, is currently in press and discusses the Paleoindian period across the Southwest. Look for it in the coming year from the University of Utah Press. We want to thank you for being here today, and on that, I will turn it over to you.
Thank you, and hello everyone, and happy Texas Archaeology Month. I appreciate being invited to talk to you all about the work we're doing at the classic Southwest Texas archaeological site of Bonfire Shelter. Bonfire Shelter is remarkable in a number of ways, but there are two particular reasons that it looms large in the minds of Texas archaeologists and in Paleoindian archaeologists nationwide. First, it may preserve evidence of the oldest and southernmost bison jump in North America. There are dense layers of bison bone in Bonfire Shelter that date to at least 12,000 years ago and potentially earlier than that. These are associated with late Paleoindian Plainview points and Folsom points as well. We think of bison jumps as being maybe more common than they were. This would be the earliest by several thousand years and the southernmost by a couple of thousand kilometers. And so this really stands out as an anomaly in Paleoindian archaeology. The second reason is that a lower layer includes the remains of mammoth and horse and other Pleistocene megafauna of ambiguous origin. Previous researchers have argued that these 14,600-year-old remains also represent human activity, but this has never really been verified. There aren't stone tools associated with them. There's nothing that we would consider really a smoking gun of human activity associated. However, if they were to turn out to be cultural, to be related to human activity, this would be earlier than Clovis and would rank among some of the earliest archaeological sites anywhere in North America. Over the course of the past 4 years or so, the Ancient Southwest Texas Project at Texas State has initiated new investigations at Bonfire Shelter aimed at addressing those two particular questions in particular. So the purpose of my talk is to provide an overview of the history of the site and its importance to the archaeology of Texas and to Paleo-Indians, its potential implications for Paleo-Indian behavior, and to report some initial results on our fieldwork over the past few years, as well as our plans for continued investigation and for stabilization and preservation. Bonfire Shelter is one of several rock shelters formed in the Devil's River limestone formations in the Lower Pecos Canyonlands of Southwest Texas, right along the border between Texas and Mexico. The canyon itself is about 20 to 30 meters deep, meaning 70 to 100 feet. It's a narrow gorge ending in a steep head cut near its confluence with the Rio Grande. This area is home to several classic rock shelter sites that have played an important role in the history of Texas archaeology. One of the key features here along the rim is this notch. And the slope beyond the rim sort of slopes upward toward this steep cliff, and then there's this notch which funnels down over the edge. Below this notch has accumulated this cone of debris called a Talis Cone, which is sediment and debris coming off the rim. And at least at 1 or 2 points in prehistory, falling bison have also been funneled through this notch in the rim. As we talk about the site itself, I'll refer to the shelter interior, which is sort of the back part of the southern half of the shelter that contains the deeper deposits, including Bone Bed 1, which is as much as 14,000 years old, probably older than 14,000 years old, but also contains parts of Bone Beds 2 and 3, which are the 12,000-year-old and 2,000-year-old deposits that I haven't even mentioned yet. the tails of those are contained in the shelter interior, but their primary location is around the Talis Cone here. So you'll see me referring to these two areas in the site as we go along in this talk. Bonfire Shelter was first investigated as a result of a series of investigations around Amistad Reservoir. And it's not really all that close to Amistad, but that was sort of the impetus for getting out there and doing research. One of the concerns was that at its highest water stand, recreational boaters and hikers and so on associated with the lake might find themselves within reach of Bonfire Shelter. It had already been sort of noted, among others by Mike Collins as a teenager, to contain bison bone on the surface and be a potentially important archaeological site. So in 1963 and 1964, David Dibble led a crew from UT and with workers from Del Rio, including notably the Hinojosa brothers, whose name can still be seen on the back wall of the shelter. It resulted in the recognition of two dense layers of bison bone in the Talis Cone, which were interpreted as bison jumps carried out by prehistoric hunters. This is one of his excellent maps from Dibble and Lorraine in 1964. And what you're looking at is a cross section of that Talis Cone. And it shows the bone beds. They've numbered them in what seems to an archaeologist to be reverse order, but it's more the traditional geological way of ordering things. And so bone bed 1 would be down here. It's not well represented at the Talis Cone, but bone bed 1 would be down here. Bone bed 2 is this Folsom and Plainview associated bison bone bed, separated by lots of rock and debris from bone bed 3, which is a 2,500-year-old bison bone bed, a separate jump associated with Castroville and Montell points. Above that is what's called the fiber layer, which is more consistent with a lot of the other sites in the Lower Pecos Canyonlands in that it has debris from plant processing. I might point out on this picture, this particular rock. You'll see this rock again in real life photos, and that'll allow you to sort of orient yourself on this profile. So in bone bed 2, they found a series of points which are morphologically quite variable, most of which fit in with what we would call Plainview, somewhat comfortably with Plainview. But it also included a Folsom point, definite Folsom point. And this, is somewhere perhaps comparable to Midland or might fit with Plainview. It's one of those things that's a little bit of an in-betweener. They got a relatively small set of radiocarbon dates, mostly based on one feature that included charcoal. These calibrate out to as early as 11,000 to as much as 13,000 years ago. We've been able to add to some of these dates, and we sort of confirm that we're looking at, the early 12,000s, the low 12,000s years ago, which would be consistent with both early Plainview and late Folsom. I might also point out that a fragment of a second Folsom point was identified in Tarl after this excavation, just a tiny little corner fragment here by folks at SMU. So that's bone bed 1 in a nutshell. Bone bed 2. Bone bed 1 is the more deeply buried Pleistocene fauna that are evident in the shelter interior. These were discovered initially by Dibble and Lorraine. They concluded that there was no definitive evidence for human activity, but they also didn't have a good explanation for what these big Pleistocene beasts were doing in the back of this relatively confined rock shelter. That got the attention of Lee Bement, who was at UT at the time. He's now the state archaeologist in Oklahoma. And he came back and along with Solveig Turpin and specifically focused on trying to get a handle on bone bed 1, which consists of horse, mammoth, bison, camel, and antelope. Some people are surprised to see horse and camel. in a Pleistocene assemblage. But there were horse here during the Ice Age, and they go extinct locally, and then they are indeed brought back by Europeans in the historic period. And Bonfire is probably best known for the mammoth, at least Bone Bed 1 is. But if you look closely, and our investigations confirm this, horse is actually more common. It's predominantly a horse bone bed with occasional juvenile mammoth and smaller bits of camel and an ancestor of modern antelope. They got a single date, which has a real wide standard deviation. So sometime between 13,300-ish, which would potentially overlap with the oldest Clovis, to as much as 16,000 years ago, with an average that would, of calibrated years, that would be about 14,600. But that's based on a single date and not a particularly good one for that matter. Bement, like Dibble, argued that there's no definitive evidence for human activity, but there's also not good competing explanations. And Bement even pointed out some features on bones that he argued may have been cut marks. They're potentially cut marks. They're also potentially scavenger marks from predators or scavengers that are using the shelter. No stone tools or features or anything that's definitively human. So let's look at these sort of one at a time. Bone Bed 2 is perhaps the oldest and southernmost bison jump that we know of in the archaeological record. Oldest by thousands of years and southernmost by several hundred kilometers. And so it sort of sticks out as an anomaly. Dibble interpreted the Bone Bed 2 as being actually 3 separate bison drives over the rim. And here you can see the depiction of that notch and an artist's reconstruction of hunters waving blankets to steer the herd over toward the edge and toward the notch. In this scenario, they fall to their deaths, and then below they are butchered near the entrance of the cave, pulled into the entrance of the cave to be butchered in the cool shade of the shelter interior. Dibble and Lorraine estimate that there are as many as 120 bison antiquus. That's a lot of animals, and that's bigger than most antiquus herds that we're familiar with at archaeological sites. It's less anomalously large if you think about this as being 3 separate events, which conforms to their interpretation. The youngest of those events is the one they have radiocarbon dates on, and it dates somewhere between 11,500 and 12,000 years old. They suggest that the oldest event may be the one that's associated with Folsom. So that's all fine and good until it was looked at more closely, first suggested by Louis Binford and then followed up on by David Meltzer and Ryan Byerly of SMU, looking more closely at the bone bed deposits and the individual elements there, and suggested another scenario that might account for this that doesn't require this sort of anomalous bison jump. They suggested that this was the remains of a more conventional kill that happened somewhere nearby, perhaps down in the canyon floor, which would have been a little bit higher in elevation in the late Pleistocene, closer to the mouth of the shelter. They argue that bison are killed in a more conventional way. Their more conservative estimate is we may be looking at something more around 24 bison antiquus, which would fall more in line with a typical Paleoindian kill. And that what this bone bed represents is selected elements from a kill elsewhere, what we call high yield elements with lots of good meat and tissue on the bone, brought back to the shelter to be butchered at that location. It's what we call a secondary processing area. And they also interpret this as a single event, arguing that the 3 different strata that Dibble and Lorraine observed are the result of redeposition, of the erosion of that Talis Cone and the redeposition of some of that bone downslope. So you might ask, why does this matter? Why is this interpretation controversial? Why does it, what implications does it have for our understanding of prehistory? There are a couple of things. One is organized game drives require considerable planning and organization and cooperation among hunters, usually among more than one band of hunters. And so using this technique has significant implications for social organization of America's earliest hunter-gatherers. Archaeological and historic data indicate that bison drives and jumps require more than a single band and are most likely associated with seasonal aggregations of multiple bands. And this is something that we haven't necessarily seen among, or we don't necessarily associate with Paleo-Indian hunters in the West, who we see as typically very dispersed, autonomous, and independent of one another. So in short, they're fairly complex events that would have required considerable coordination and some degree of hierarchical organization. In other words, some degree of leadership. So earlier this year, we returned to Bonfire Shelter to initiate new research under ASWT, which is the Ancient Southwest Texas Project at Texas State University, brainchild of Dr. Stephen Black, who I think might be presenting another one of these in this series. Our goals for Bonfire Shelter are to establish a detailed chronostratigraphic sequence for the deposits, meaning get a better handle on the age of all these deposits. Most of the radiocarbon dates that we have for the site were run before the 1990s, before we had better calibration, better techniques, AMS, radiocarbon dating, and so on. Secondly, we want to determine the origin and the number of events associated with bone bed 2. Specifically, is it a bison jump? And if so, if it is it more than one bison jump? That would suggest that not only are bison jumps being carried out this early, but they're being carried out with some regularity, at least on this portion of the landscape. A third goal is determining the origins of bone bed 1. Specifically whether or not it's related to human activity. Is bone bed 1 an archaeological site? And if so, is it as old as that single radiocarbon date suggests? I may disappoint you by not having definitive answers to these questions today. These are things we're continuing to work on, but I'll give you some information on what we've surmised so far. Along the way, we're also working on constructing a 3D model of the whole site. Using photogrammetry. So basically using software that takes photographs and molds them over a three-dimensional mesh that you create with surveying software to reconstruct not only the shelter itself, but in greater detail, the individual profiles and excavation units and samples that we're collecting, and be able to sort of geo-reference them to that big 3D model. So it's been sort of a fun experiment in what are, to me, cutting edge field techniques as well. And then lastly, our goal is to preserve the site by backfilling these excavations from the 60s and from the 80s, which had never been fully backfilled and were being affected by erosion and slump and other factors that are potentially damaging the site. Ultimately stabilizing the surface and covering any exposed deposits for the sake of preservation. So here is the work that we've done. One of our approaches has been, and this is the philosophy of ASWT in general, which is low impact, high resolution and low impact, high resolution data with a low impact on the archaeological deposits. And toward that end, we've mostly tried to emphasize cleaning up existing profiles rather than doing a lot of new excavation. And so in the shelter interior, that means cleaning this long profile here. This is a very deep profile that gives us all of the stratigraphy. This one as well. The larger blocks are excavation, but they are excavation only in bone bed 1. So these had already been excavated, but they were excavated to the top of bone bed 1. We continue those excavations a little bit deeper. These smaller little notches here represent column samples in which we're collecting data from each of those stratigraphic units. In the Talis Cone, we sort of did the same thing. Starting in 2017, we herked all this material out and cleaned up this profile. This is that view that I showed you of Dibble and Lorraine's figure with the big rock in the middle of it. A couple more column samples there. 2018 and 2019, we expanded that to the south side of the Talis Cone and to the east side, so that we have, you know, a pretty good view and profile around the edges of this Talis Cone without doing a whole lot of new excavation to the Talis Cone itself. So in other words, all of this remains preserved. We did do some smaller excavation areas as well that sort of came up opportunistically. This one was put in because it's not well reported what was found over here. And it turns out that we discovered that the reason for that is because not much is found over there. Except parts of Bone Bed 3 actually make their way all the way over here. There is some juvenile bison associated with Bone Bed 3, which make it that far north in the shelter. So what I'm going to show you next are some closer up views of this particular profile in this area and of this profile here. So now down in the shelter itself, this is the shelter interior. This orange mesh is protecting the Talis Cone that was put in place by Elton Pruitt back in the 90s. And so that, just to orient you, that's the Talis Cone. This is the deep excavation units in the shelter interior, largely as we found them. So you can see all this wall slump, you can see the erosion. This is where we put in a little bit of a test to see if we could differentiate the origin of some of that slump in order to be able to screen it separately. Turns out we couldn't very well. But after lots and lots of labor and getting it cleaned out, we were able to clean up the profile, get down to the bottom of the excavation. This is Sean Farrell here, who's doing his thesis on Bone Bed 1. So we did excavations here in Block C, and where this light is standing is Block D. These are the Bone Bed 1 excavations that we continued. Over to the Talis Cone. So if you peel that back, this is what you find. You can see where we've cut the mesh back right there. These are part of the crew that are digging out the backfill from this area. This had been backfilled, and so it's lots and lots of sediment. It doesn't look like it because the difference is so extreme, but this is taken from that same angle. This is how deep that trench is. Here's that big rock on Dibble's profile that I pointed out. So that maybe sort of orients you over here. One of the things that stands out immediately is Bone Bed 3, which is this 2,500-year-old late Archaic bison jump. And the whitish parts are white because they're heavily burned, and the black scorched part underneath is the result of the burning as well. You can even see the limestone boulders that are in there are burned. This is the namesake of the site. This is why it's called Bonfire Shelter. Bone Bed 2, actually, those may be bones right there, is burned in places, but is mostly unburned, and it dives just under that rock and is about the level of Charles's ankles in this photo. So what I'm going to show you in the next couple of slides are these profiles cleaned up. I'm going to show you this profile right here and this profile right here. This is the main profile in the shelter interior. And you can see that all three of the bone beds are represented down there. Bone Bed 1 is pretty high in the profile. These are actual bison bones sticking out of the profile wall there. Bone Bed 2 is much lower. They're separated by more sediment in the interior than they are in the Talis Cone. Couple of bones evident down here in Bone Bed 2. There's a little remnant of a feature in between. We'll come back to that. That's a little charcoal feature. And these several strata, 23, 22, 23, and 24, represent Bone Bed 1, which unlike these is not a compact, discrete bone bed. It's really multiple strata that contain a scattering of bones. This is sort of gives you an idea of the depth of Bone Bed 1, this profile you're looking at is actually over here. This is Dr. Marcus Hamilton, who's at University of Texas at San Antonio, excavating a metapodial from a horse. So this is one of those Pleistocene horses that are pretty frequent in bone bed 1. This is an example of our 3D photogrammetry. If we were live in the software, we could spin that around and zoom in on it and mark where particular samples came from and so on. But the important thing here is what you're looking at are mammoth bones. That is a mammoth rib there. This is part of a mammoth pelvis. We have horse remains in here. We have other splintered bone. So this is sort of the condition of bone bed 1. One of the things you might notice is it's in pretty bad shape. But you got to give it a break because it's 14,000 years old. It's been lit down there a long time and buried under the pressure of a lot of rocks and debris. Over to the Talis Cone. This, again, is that same drawing I showed you from Dibble and Lorraine, but this is our 3D model of that. And you can see bone bed 3 and bone bed 2. Bone bed 3 consists of multiple strata that may represent, to us, it looks like it represents a single event, a single large event that then all burned. And if you look at that closely, it's just chock full. All of that white layer is burned bison bone. And this chalky white stuff is also burned bison bone that's just burned so heavily that it's reduced to a powder. I get this interesting phenomenon along the bottom, and it doesn't come through terribly well in this, but it's almost sort of bluish in color. And very, looks like slow, burned very slow and hot. And we interpret that as probably pooled tissue from the decomposition of this bone bed that when it caught on fire, burned like a kerosene lamp, slow and hot for a long time, scorched the sediments underneath it. These two, this is on the north side, there are 2 different strata that contain bone bed 2. You can see these yellow bits here are bones that have been highlighted artificially. It comes in 2 strata that dive down under this big boulder and continue down there. And so one of the implications is that this boulder either came down as a result of all this activity or came down shortly after and landed right on top of it. In my thinking, this may have been something that was dislodged as a result of bison jumps and either was precarious and fell a few years later or maybe fell immediately afterward. We put in 2 of our column samples here, and these are sort of mini excavation telephone booths. And so we go down 1 stratum at a time and collect 100% of the sediments. The point is to be able to take those back to the lab and do geological analyses and do paleoenvironmental analyses and so on with those. Even though the target really is the sediments, in the process of doing those 2 column samples, we came up with additional artifacts. These are the Castroville style points that are found that are associated with bone bed 3. And in addition, found at least 1 more nearly complete Paleoindian lanceolate point down here in stratum 11 associated with bone bed 2. I think we've got a better picture of these coming up. Yeah, these are in, if you're interested, we just had an article come out in Plains Anthropologist that reviews all of this new information. But each of these, that also came out of that profile in bone bed 2. So these are definitively Paleoindian, bits of Paleoindian projectile points. This one was in the slump nearby, but morphologically it's consistent with the Paleoindian occupation and the raw material as well. Both of these are associated with bone bed 3, and one of the differences you can see immediately is how heavily burned they are. You can see the pot lid here, the crazing and fracturing on these, which is another indication that maybe this isn't associated with bone bed 3 because it's not burned. I was going to reorient you to now the south side of the Talis Cone. And so beginning in about 2018, we opened up this profile. This is the area where Dibble and Lorraine report 3 separate strata in bone bed 2. And that's, this is Marcus Hamilton again, in front of that profile wall. And this is the strata that they're referring to. So you have, let me zoom in on this, all of that is bone bed 2, an unburned stratum, a burned stratum, and a third unburned stratum. Zooming in on that a little bit, you can see how distinct those are. So Dibble and Lorraine interpret this as being three separate events. One of them which caught fire probably as a result of a nearby hearth. Byerly and Meltzer interpret this as one single event, which then eroded and things washed down on top of it to create additional strata. And sure enough, you can't really trace these distinct three strata all the way up into the peak of the Talis Cone. They become evident more toward the slope of the Talis Cone. We have two students doing master's theses looking at this, one looking at the zooarchaeology, looking at the bison bone itself to determine whether they are consistent with the jump and to determine whether there is any evidence for more than one event. This is James Ramsey at Texas State, and he concluded that there is nothing in the bones that indicate that they are that multiple seasons are represented. Meaning that if you can get at seasonality by the tooth eruption patterns of bison. And there's nothing that indicates that this happened at more than one time of year. So that means either it is one event, or if it's multiple events, they were all carried out the same time of the year, which is also a possibility. So the zooarchaeology supports one event, but the damage to the bones and the placement of the elements do support the idea of a bison jump. And one of the reasons for that is we see articulations within the profile. This is the head of a femur. It's still in the socket for the pelvis. These aren't the kinds of things that you would drag up into the shelter as a secondary processing area. This looks like part of a whole intact animal. That was there in the shelter, which supports the notion of this being a primary kill and a bison jump. James Ramsey also discovered lots of green stick fractures, lots of bone breaks that would be consistent with a fall from a great height. Our other approach to this, which is still in progress, is Ashley Iington, who's looking at the geoarchaeology of these strata, trying to evaluate whether these appear to represent geologically three separate events. And she should be finishing up in the next several months. So hopefully we'll have some results there before too long. Along the way, we encountered a couple of archaic features that hadn't been thoroughly investigated. This is one of them right here. It sort of looks like a smiley face. It's a campfire or a hearth in cross section. We discovered this is it partially excavated. You can see that it's filled with heated rocks, heated and thermally cracked rock. We got 3 radiocarbon dates that calibrate an average to about 5,000 years ago on this feature. In the process of doing the column sample, I told you we came across another feature, which was chock full of charcoal. That one dates almost 2,000 years earlier, 6,800 BP. And we were able to do, with Phil Daring, able to do some macrobotanical analysis. And interestingly enough, both of these campfires had lots of fuel wood, but very little in the way of edible things, of subsistence items. And so it looks like these fires are more for heat, perhaps for cooking, than they are for direct processing of edible materials. These together indicate use of the shelter between the things that it's famous for. So there's bone bed 2, there's bone bed 3. Both of these occur in the intervening sediments during the Middle Archaic. This is an example of one of our 3D column samples. This is where that Plainview point came out, as actually haven't excavated that far down yet. But this is sort of a notion of what we're able to capture with the 3D photography. We can also indicate exactly where samples come from. And so when we collect a sample, you take a photograph with that sample marked on the profile, that becomes part of the 3D model if you want it to be, and then you can not only know exactly where it came from in space, but you can actually visualize what that sample was and what its associations were. As I mentioned before, we don't have a lot of definitive conclusions yet. I will say about bone bed, one, Sean Farrell is completing his thesis now, and he has not been able to find any definitive evidence of human activity. It is, however, consistent with some other animal dens, particularly Homotherium, which is a saber-toothed cat, who were big fans of hunting horses and might scavenge the occasional juvenile mammoth. We got some more radiocarbon dates on bone bed 1 and can confirm that it's about 14,500 years old. But so far, no smoking gun that it is actually an archaeological site as opposed to a paleontological site. Current evidence suggests that bone bed 2 does represent a bison jump. We're still working to figure out if it represents more than one. And just, I guess, in wrapping things up, I've got a student now who's working on bone bed 3, the latest one, to try to look at the evidence for hunter-gatherer cooperation in these big bison hunts in the late Archaic period in Texas. That's Alda Magaha, and she's taking that on as her thesis. So in sum, I want to thank you again for inviting me. Thanks to all the people who have helped us carry out this research, including the THC in the form of Texas Preservation Trust Fund grant to help us do the stabilization work in the site. And again, I appreciate the opportunity to share this research with you guys on Texas Archaeological Month.
Dr. Kilby, thank you very much.
Yes.
If any of our viewers have any questions, feel free to ask them in the comment section below. Thank you.